For short, I would like to present you how the logarithmic paper looks like. This is a part of a logarithmic paper. So if I put a ruler and I say this is the x-axis, in our case this is omega, and this axis is, for example, the k omega. Of course it can be the phi omega. Let's say this is k in decibel omega. For example, this value can be 1. Omega is equal to 1. Here omega is equal to 10. Here omega is equal to 100, and so on. This value is 0.1. So if it is true, we can say that this value is 2. This value is 3. This value is 4. This is 5. This is 6. This is 7. So the lines are becoming closer and closer. So this is 8. This is 9. And this one is 10. So in the next, this will be not 11, but 20. This will be 30. This is 40, 50. This is 60, 70, 80, 90, and 100. So in the next, this value is 200. Okay, this value is 0.1. This value is 0.2. This is 0.3, 0.4, and so on. So the same distance between the decades. So for example, if we say this is 1 decade between 1 and 10, the same distance, for example, between 3 and 30, this is also 1 decade. But, for example, between 0.4 and 4, this is also 1 decade, and so on. This is how to use the logarithmic scale on omega, and it's very easy to see that in this very simple example, this value is 0.1 and this value is 100. So the frequency range can be very wide in this case. Okay, but what about the k-axis? So this is the 0 dB, for example. The typical notation is that this is 20 decibel. This is 40 decibel. This is minus 20. This is minus 40. It's a kind of typical application in this case.